All right. Time to get those thinking caps on because we're diving deep into something super interesting today. First principles thinking for coders. We're cracking open this article called The Power of First Principles Thinking in Coding, Solve Any Problem from Scratch. And let me tell you, it's like a breath of fresh air for anyone who's ever felt stuck in a rut with their code.
Absolutely. It's about breaking free from those prepackaged solutions, the ones we often rely on, and really getting down to the bedrock of how things work.
Yeah, totally. No more Googling for the quickest library or framework. We're talking about channeling our inner Elon Musk here. Think SpaceX landing rockets. They didn't just tweak someone else's design, right? They rethought the whole process from the ground up. That's the kind of thinking we're exploring here.
And what's so cool about this approach is that it's not just for rocket scientists. It's for anyone who writes code.
Mm.
It's about shifting your mindset from how is this usually done to what are the fundamental principles at play here?
I love that. So how does that actually translate into writing better code?
Well, think about it this way. Imagine you're trying to sort a list of numbers. Most of us would instinctively reach for our trusty quicksort or merge to sort algorithm. And those are great tools, don't get me wrong. But with first principles thinking, you take a step back and ask yourself, how could I arrange these numbers logically if I had to start from scratch?
It's like forgetting everything you know and approaching the problem with fresh eyes, right?
Exactly. So instead of relying on pre-built functions, you start thinking about the simplest steps involved in sorting. You might say, okay, I need to compare each number to the others and figure out their order. If I find a pair that's out of order, I'll swap them.
Oh, so you're basically reinventing bubble sort without even realizing it.
Precisely. You might stumble upon bubble sort, or you might come up with something even more interesting. The point is, you're building that understanding from the ground up, and that's where the magic happens.
That makes so much sense. It reminds me of how I used to memorize formulas in math class without really understanding what they meant. But when I took the time to understand the underlying concepts, suddenly the formulas made so much more sense, and I could even apply them in different ways.
Exactly. And it's the same with code. When you understand the why behind the how, you unlock a whole new level of flexibility and creativity in your problem solving.
So it's not just about finding any solution. It's about finding the most elegant and efficient solution by understanding the core principles at play.
You got it. And the best part is, this approach scales. We've been talking about sorting, which is pretty fundamental, but first principles thinking works for much more complex problems too.
Okay, I'm intrigued. So let's say we're dealing with something a bit more challenging, like designing a cache system. That's getting into some pretty meaty territory, right?
Absolutely. But even with something as complex as a cache system, you can apply the same principles. We break it down. A cache is basically a temporary storage space, right? It holds data that we've recently accessed so we can retrieve it quickly next time without having to go all the way back to the main source.
So it's like a shortcut for our data.
Precisely. Now, because a cache has limited space, we need a system for deciding what to keep and what to discard.
Makes sense. You don't want your cache overflowing with outdated information.
Right. And one common approach is to use something called an LRU cache, which stands for least recently used.
Okay, so with an LRU cache, you're essentially keeping track of which pieces of data have been accessed most recently and prioritizing those.
Exactly. The idea is that the data you've used most recently is more likely to be needed again soon.
So applying first principles here, we've identified some core ideas: limited storage space and prioritizing recently used data. And those core ideas essentially lead us to the concept of an LRU cache. That's pretty cool. It's like the solution emerges naturally from understanding the problem's essence.
That's the beauty of it. And it doesn't stop there. Let's say you're tasked with building something even more daunting, like a simple database.
Okay, building a database from scratch. Now that sounds intimidating.
It might seem that way, but with first principles thinking, even a complex system like a database can be broken down into manageable chunks. First, you ask, what is a database at its core?
Well, it's essentially a system for storing and retrieving data in an organized way, right?
Exactly. It needs to provide certain basic functions. We need a way to create new entries, read existing entries, update entries, and delete entries. You got it. We often refer to these as CRD operations: create, read, update, delete. These are the fundamental building blocks of interacting with data.
Okay, CRD operations, I'm writing that down. So how does first principles thinking guide us in actually implementing these operations?
Well, let's think about the simplest way to store data persistently. We could use files, right? Imagine each entry in our database is a separate file, and the file name is our unique identifier.
So to create a new entry, we just create a new file with the relevant data in it.
You got it. And to read an entry, We open the file with the corresponding name and retrieve the data.
And updating would just be overwriting the file with the new data. And deleting would be deleting the file entirely.
Exactly. It might not be as sophisticated as a full-blown database management system, but it captures the core principles. We've essentially built a basic database using the fundamental concept of file storage.
That's amazing. By breaking it down to those core principles, it doesn't seem nearly as intimidating anymore. It reminds me of how we often overcomplicate things in coding when sometimes the most elegant solutions are the simplest ones.
I couldn't agree more. And that's one of the most powerful aspects of first principles thinking. It helps you cut through the noise and see those elegant solutions that might otherwise be hidden beneath layers of complexity.
So we've seen how this approach works for both simple tasks like sorting and more complex challenges like designing a cache or even a basic database. But let's talk about the elephant in the room. What about when we're working within existing systems? We don't always have the luxury of starting from scratch. How does first principles thinking apply when we're dealing with legacy code or established architectures?
That's a great question. And you're right. In the real world, we're often working within constraints. But that doesn't mean first principles thinking goes out the window. It actually becomes even more valuable in those situations.
How so?
Well, let's say you're tasked with extending the functionality of an existing piece of software. It's tempting to just dive in and start writing code based on what you see. But with first principles thinking, you take a step back and try to understand the why behind the existing code. What were the original developers trying to achieve? What constraints were they working with?
So it's like becoming a code archaeologist. You're digging through the layers of code to uncover the fundamental principles that guided its creation.
I like that analogy. By understanding those original principles, you're in a much better position to make informed decisions about how to extend the software in a way that's consistent with its original design and intent. You might even uncover opportunities for simplification or optimization that weren't apparent at first glance.
That's so smart. So rather than just layering on more code, you're using first principles thinking to ensure that any new code you write is aligned with the underlying foundation of the system.
Precisely. It's about working smarter, not harder. And that's what makes first principles thinking such a powerful tool for any coder, whether you're working on a brand new project or maintaining a legacy code base.
It's like having a superpower for navigating the complexities of the coding world. Now, we've talked a lot about the practical applications of first principles thinking, but I'm curious about the broader impact. It sounds like this approach could influence not just how we write code, but how we think about problem solving in general. Would you say that's accurate?
Absolutely. First principles thinking isn't just about code, it's a mental model that can be applied to any field or challenge.
I love that. So it's like a mental framework for approaching any problem with clarity and a focus on understanding the fundamentals.
Exactly. And as coders, we're fortunate to work in a field where those fundamentals are often laid bare. Code is logic made tangible. It's a great training ground for developing your first principles thinking muscles.
Now, this might be a bit of a curveball, but our outline mentions something about applying first principles to different programming paradigms. I have to admit, that one threw me for a loop a little. Can you elaborate on that? What does it look like to apply first principles thinking to, say, object-oriented programming?
Great question. Remember when we talked about breaking down complex systems into manageable chunks? Object-oriented programming is all about that. It encourages us to model our code after real-world objects, each with its own properties and behaviors.
Right, like thinking about a car as an object with properties like color and model and behaviors like accelerate and brake.
Exactly. And when you apply first principles thinking to object-oriented design, you start by asking, what are the essential objects in this system? What are their core attributes and actions?
So using the example from the article, if we're building a library system, we might identify objects like book, patron, and loan.
Precisely. And we'd think about their attributes and behaviors. A book might have an author, a title, an ISBN, and behaviors like checkout and return. A patron might have a name, a library card number, and behaviors like borrow book and a return book.
And by breaking down the system into these fundamental objects and their interactions, we can create code that's more organized, modular, and easier to reason about.
Exactly. You're building up complexity from a foundation of simple, well-defined components. That's the power of first principles thinking applied to object-oriented programming.
That makes a lot of sense. And it seems like that same principle of breaking things down into fundamental units could also apply to functional programming, right?
Absolutely. Functional programming is all about breaking down computations into pure functions. functions that always produce the same output for the same input and have no side effects.
I remember learning about pure functions. They're like the math equations of the programming world.
Exactly. And when you apply first principles thinking to functional programming, you start by asking, what are the core operations I need to perform on this data?
So instead of thinking about data as objects with methods, we're thinking about it as values that we manipulate with functions.
Exactly. Let's say you're doing some numerical processing, like calculating the average of a list of numbers. In a functional approach, you might break this down into a series of pure functions. One function to sum the numbers, another to count the numbers, and a final function to divide the sum by the count.
So we're essentially chaining together these simple, pure functions to achieve a more complex calculation. It's like building a data processing pipeline, where each step performs a clearly defined transformation.
Precisely. Each function is like a building block, and by combining them in different ways, you can create complex data transformations while keeping your code clean, modular, and easy to test.
That's incredibly powerful, and it really highlights how first principles thinking can be applied across different programming paradigms, helping us write better code no matter what approach we choose.
It's all about adapting the principle of breaking down complexity into fundamental units to the specific paradigm you're working with.
This has been incredibly eye-opening. But let's be real, it's not always easy to put these principles into practice, is it? I mean, as coders, we all have our ingrained habits and go-to solutions. How do we break free from those comfortable patterns and force ourselves to think from first principles, especially when we're under pressure to deliver code quickly?
You're absolutely right. It takes conscious effort to shift your mindset and challenge your assumptions. It's like building any new habit. It takes time and practice.
Yeah, it's like you're saying that first principles thinking is less about memorizing specific coding tricks and more about developing a mental toolkit for tackling any problem that comes our way.
Exactly. It's about cultivating a mindset of curiosity and a willingness to question everything. And the more you practice that mindset, the more natural it becomes to approach challenges from a first principles perspective.
It's like building a mental muscle for breaking down complexity and uncovering those elegant solutions that might have been hiding in plain sight.
Precisely. Now, one thing I want to emphasize is that first principles thinking isn't about reinventing the wheel every time you sit down to code.
Right, we don't need to start from scratch with every line of code we write.
Exactly. It's about finding that balance between understanding the fundamentals and leveraging the tools and libraries that are available to us. Sometimes, the most elegant solution is to use a well-established library or framework.
So it's not about being a purist, it's about being pragmatic.
Absolutely. First principles thinking gives you the knowledge and confidence to make those judgment calls. You understand the trade-offs involved in using a pre-built solution versus building something custom because you understand the underlying principles.
That makes a lot of sense. It's like you can appreciate a well-crafted car without having to build one yourself, but understanding how the engine works makes you a more informed driver.
I love that analogy. It's about being an active participant in your craft, not just a passive consumer of tools.
This has been an incredible deep dive, and I feel like I've gained so much clarity on this whole concept of first principles thinking. But before we wrap up, I want to circle back to something you mentioned earlier about the broader implications of this approach. You said it could influence how we think about problem solving in general, not just in coding. Can you expand on that a bit more?
Absolutely. You see, the challenges we face as coders often mirror challenges we encounter in other aspects of life. We're constantly bombarded with information, trying to make sense of complex systems, and seeking elegant solutions to messy problems.
And you're saying that first principles thinking can help us navigate those complexities regardless of the context.
Exactly. Imagine applying this mindset to your personal finances. Instead of blindly following the latest investment trends, you might take a step back and ask yourself, what are the fundamental principles of building wealth? What are the core factors that determine financial success?
So it's about cutting through the noise and focusing on the underlying principles that drive results.
Exactly. Or think about applying first principles thinking to your health and fitness. Instead of jumping on the bandwagon of every new diet or workout fad, you might ask yourself, what are the fundamental principles of human physiology? What are the core elements of a healthy lifestyle?
So it's about understanding the why behind the what, just like we've been talking about with code. By understanding those fundamental principles, we can make more informed decisions and avoid getting sidetracked by quick fixes or superficial solutions.
Precisely. First principles thinking empowers you to become a more critical thinker, a more effective problem solver, and ultimately a more discerning individual in all aspects of your life.
This has been such an eye-opening conversation, and I feel like I have a whole new lens to which to view the world, not just my code. So as we wrap up, if there's one key takeaway you want our listeners to walk away with, what would it be?
If there's one thing you remember from this deep dive, let it be this. Never stop asking why. Question your assumptions, challenge the status quo, and always strive to understand the fundamental principles that govern the systems you interact with, whether it's a complex piece of software or the complexities of your own life.
Embrace the power of first principles thinking, and I guarantee you'll unlock new levels of clarity, creativity, and effectiveness in everything you do. Thanks for joining us on this deep dive, and until next time, happy coding.